A 5 kilogram block slides down a frictionless plane with an inclination of 15 degrees. The block starts from the rest at the top, and the length of the incline is 2 meters. Find acceleration and speed of the block when it reaches the bottom of the incline. So first, let's look at all of our given information. And so we also drew the block up here. So we know that the mass of the block is 5 kilograms. The length of the incline is 2 meters. Our theta is equal to 15 degrees. Initial velocity is 0 because it starts from rest. Our initial position is 0 and our final position is 2. And so we're trying to solve for the final acceleration and for the final velocity. So first we should draw our free body diagram. So we'll label our forces which are acting upon it, which we have force of gravity and our normal force. And so with Newton's second law, we can say that sum of the forces is equal to ma. And so we can say that the forces in the x direction are equal to mass times acceleration. And so we can actually visualize this and say that this is our x-axis and this is our y-axis right here. So when we draw a triangle, this is our theta. And one sec. All right, so then we can say that our force in the x direction is equal to mass times gravity times sine theta is equal to ma. So we can cancel out our mass, and we can say acceleration is equal to g sine theta, which if you plug in the numbers is equal to 2.54 meters per second squared. And so from there, we can relate that to our kinematic equations. And we know that velocity final squared is equal to velocity initial squared plus 2 times acceleration times delta x. So with our given information and what we solved for, we can say that Vf squared is equal to 0 plus 2 times a delta x. And so we know that our acceleration is here, and our delta x is 2 minus 0. So we can say that our final velocity is equal to 3.2 meters per second. And so that's how we can solve for a block sliding down a frictionless incline at an inclination of 15 degrees.